Hello and welcome to my first devlog. So, we're going to be starting a new game where I think the concept is essentially going to be a auto robot battler, similar to the mobile game Cats, if anyone has ever played that. I think it's going to be similar to this here, which essentially you build out a robot to battle, and once you build it out, you can unlock new loot to put on your robot, and then you essentially battle other robots that other people have created. And I think we can do a fun spin on it, or kind of use the simulator esque loot box type thing, where you unlock loot through grinding that out by like beating NPCs and stuff like that. I think this is gonna be really fun to code. So essentially, it's gonna be a lot of 2D rigid bodies. So it's gonna be a lot of math. But I think it's gonna be a lot of fun. So let's get started. So I'm thinking that the bots will essentially have 4 classes of things that are attached to them. So there's obviously the body, like the main chassis, the wheels that go on it, a weapon or 2 potentially, and some gadgets. Gadgets will be like kind of utility-based things, and everything here needs to have kind of physics in a sense tied to it. It has mass. It has for wheels, they have grip, which is like their coefficient. They also have, a radius, things like that. And then, since we're essentially going to be creating our own physics engine here, we also need to map out the vertices on the bodies themselves. So this will be, it's going to get pretty complicated, but I just wanted to bring up another point here. When I said 2D physics, the actual robots and stuff will actually be in 3D, like a regular Roblox game, but they'll be constrained to this plane, essentially. So it would look something like this. We have a plane here that they are constrained to. So it's kind of a 2.5D in a sense. I just wanted to clear that up because I might have been a little confusing there. Alright, after a lot of work, I am using the new edible images to essentially create the simulation of the code that I've written so far. So this is our robot with 2 wheels on it, and my physics don't quite work, which you can tell because it's flying up and rotating for some reason. But this is so cool. We have these are all drawn by using the edible images. We have a running physics simulation. Like I said, it is it's not a good simulation, but it's running in real time. I'm gonna set the parts body right here to a shape hexagon and see what happens. Yo, look, see? Isn't this so cool? I'm just gonna name this wooden 2 for now. Let's make this radius much bigger, like radius of 5, and a mass of, I don't know, 20. I'm just making up numbers. So now when I go over here, and let's make one of the wheels be wooden 2 instead. And now you can see our back wheel is bigger than our front one. So this is kind of the way I'm thinking of doing it. And essentially we're gonna be running these simulations in real time. But instead of it being on UI, it'll be using the 3D instances, using parts and models and whatnot in it. But by doing it this way, it's so much easier to test and realize what's happening, because then I don't need to click play. It's just all doing it in real time on an editable image. This is awesome. Okay, after many hours, we have basic collision detection and gravity. Still kind of a lot to do. This is a lot harder than I expected it, but it's been fun so far. And yeah. Oh, I don't know what that was, but did a little jump there. So I think I've gotten some decent collision detection working. Kind of ended up redoing a lot of it, and this is what I'm left with now. So we're able to collide, and it stops there. I also made a system where I can pause the simulation and do one frame at a time and kind of step forward. It's made debugging this a lot easier, because I was having some issues where they'd kind of clip inside of each other quite a bit. But I have kind of completely started over because I think my old system, I was kind of trying to take a couple of shortcuts, and I'm going back to the basics, where it's essentially I was trying to add the wheels before I had bodies, in a sense. So you can see glancing below here, and they drop down with gravity. And interestingly, you know, let's set this, or actually let's set this one's mass to much higher. So if I go into my setup, let's say that the first bot's mass is 400, so 4 times more than this mass. When I click play, you'll see now it pushes that one off to the side, which is really cool. You can totally tell that the physics here makes sense. Now there's a little bit of an issue if let me get rid of the second bot real quick, and let me set the angular velocity to this one of like 3 and like 10 there. So it'll just fly up, but it kind of just rotates on the ground forever. You'll kind of see this. There isn't like a friction or some other way. You'll notice it's gonna just rotate and rotate and rotate, where that doesn't really make sense. So I need to kind of come up with some like essentially ground forces or contact forces, I think is what it's called, but that's kind of what I'm gonna work on next. Alright, I think I've found my issue. So I've added some more to the debug screen here. So when I click play, we can see this blue line is the velocity that each part has. The green is the centroid, so the center of mass. And then if I click play and do it frame by frame, you can see, you know, we started with some initial velocity, it was going up, and then gravity has pulled it down. There's these purple dots now. So whenever a collision is detected, you'll see that we have a purple dot. That purple dot is supposed to actually be where the collision has taken place. So it should be right here, but it's being calculated and incorrectly being put right here. And that, I think, is what's causing it to spin indefinitely, because essentially we're applying a force with an origin here, which would then, you know, push up and cause it to then spin indefinitely. So if I click play, you can see, imagine a force being applied constantly in this direction. Obviously it's going to keep on spinning and spinning and spinning and spinning and spinning. And to kind of prove that that's what's happening, if I set the position to be the middle of the ground part, you'll see, since the computed origin point happens to actually be the correct value, which would be right here, we don't get that spinning anymore. Where if, let's say I take this exact same simulation but move the part over just a little bit, so if I set the position to like 60 instead, you'll see we're coming down, but it's incorrectly determining the impact to be right here, because right now it's just essentially taking the midpoint of the two centroids, and that's causing, you know, a force to be applied going this direction, like I said earlier, and that force just constantly going up and up and up and up and applying and causing weird interactions. So I'm gonna see if I can figure out a way to hopefully get a better collision point detection. So something I just realized was when filming that last clip was that the part was clipping to the ground quite a bit, and I wasn't actually sure what was causing that. But if you look at this clip now, you'll notice that it's not clipping as much, or barely like at all. I mean, you can maybe see a tiny bit, but it's barely clipping now, which is great. And it was a tiny little change. So in my logic here, in the physics engine update, all I changed was this loop down here was being calculated after the collision check. So it'd do the collision check first, and then it would update the objects, which is, you know, the whatever the forces are being applied to the object. It would then send the update signal. So this is how it was before these changes. And you'll notice clipping in the ground because we're doing the collision check, but then we're doing right after it the force updates, and then it would wait until the next frame. So essentially I was just doing it in the wrong order. It's a small thing, but it's been bothering me, and it was as simple as moving like 5 lines of code. Pretty easy. I also changed it to be night mode on this screen because it was hurting my eyes. Okay. Back to collision point checking. Imagine this. We have a rectangle here defined by some vertices. And then we have a triangle, like so, defined by some vertices as well. Essentially what I'm going to be doing is using an algorithm, I have no idea how to pronounce his name, to compute the intersecting shape of 2 convex polygons. So if I then draw the intersecting shape in blue, you'll see that it's here. Let me hide the other shapes. You can see we now have an intersecting polygon. And now we can compute the centroid of the intersecting polygon, and that will be our action, or our contact point. I think I did it. Look at this. So now the collision point, you can see, is looking good. It's actually where the collision's happening. I do notice there is a weird on impact. The very first collision point's over here. I don't know what would cause that. It's really dumb, my issue. Apparently for the algorithm that I'm using, I don't even know how to say it. Sutherland-Hodgman clip. The vertices need to be sorted in a counterclockwise order. That was my issue. This bottom here, or the ground, wasn't sorted in a counterclockwise order. Yeah. So that's an hour of my life I'll never get back. It's probably more than an hour. But yeah, so that is looking really, really good. I just want to illustrate why we went the route of doing this whole making our own physics engine, because maybe I wasn't super clear on that. What's really important in these auto battler games, or just any game of this nature, is that everything needs to be determinate. And what I mean when I say that is the exact same inputs need to always give the exact same outputs. And this is really important for this kind of game, is because you go and watch someone's YouTube video and you see this crazy build that they threw together. You want to go try that. So you put in the exact same thing that they did. You should expect to get the same output. So in this scenario here, I'm going to play this, this collision of 2 rigid bodies with these vertices for their polygons, and you're gonna notice that the exact same thing happens every single time. You can take a look at this rectangle block, because I think it's important to look at. It just barely tips over each time, and this is so important for this kind of game. And it's something that, unfortunately, the Roblox physics don't really help with. Roblox physics, I think, are notoriously jank. I think we're going to have our fair share of jank here too, but it will be predictable jank. And I think that's going to be the theme of this game, predictable jank. I love it. So I've got this simulation set up so that we have two bots essentially with different shapes that are having forces being applied to them going into each other. I have it set up so that the first bot's mass is 300 and this one's 100, and I think this little demonstration will kind of show why this was important to do. So if I go ahead and press play, you can imagine this as two bots pushing into each other and then doing some actions. And we can now define what the bots' shapes look like, you know, their masses and things of that nature. I think this really clearly demonstrates kind of what the whole thought process was here. And I think everything looks great, you know. We can make it so that, I don't know, let's say this one's mass is actually higher now. Press save. Now this one will push that one because it has a higher mass. Yeah, it's pretty cool. We have wheels working, or circles I should say, in the physics engine. So if I go ahead and press play, you'll see they're able to interact with the world around them, and they are colliding. And you'll see they push onto each other like that, and yeah. They do clip like a little bit, but that's actually, I think, going to be good because we don't want like the wheels floating above the ground typically in real life or just in video games in general. That's kind of how they end up looking anyways, because they kind of squish into the ground in real life. So I think that will be perfect. And yeah, we have a cool system going here. Alright, I've created a stress test for the simulation. I have two hexagonal weird polygons shaped things in here, and I set their torque to a ridiculously high number, and so basically their angular velocity will end up being ridiculously high because it has constant force applied to it. So if I go ahead and press play, this is the stress test that I've created. It's almost like a Beyblade battle. But it actually looks like it's working like pretty dang well. I mean, everything, even in these crazy scenarios, it passes the eye test, which I think is really important and kind of displays that I think we have a working simulation prototype physics engine here. So next step is going to be attaching the wheels to the bodies of the car. So essentially what we need to do is create some type of constraints. Check this out. Look at that. We have a bot with wheels attached to it, interacting with the world around it. Pretty cool, right? Look at that. Beautiful. Replay this as much as I want. And yeah, we got wheels spinning, which is essentially anchored to the robot. I also added in collision groups because the wheels were obviously colliding with the robot itself, so they need to be separate collision groups, which is really important. And yeah, I think it looks really, really good. I think we've made so much progress. It's crazy. I'm gonna quick throw together another bot and have them face off against each other and see what that looks like. Okay, I have two bots right next to each other, and they're gonna fight it out. So I'll start the simulation. This one's wheels a little bit on the ground, so it can't get more enough speed, and it seems like this one kind of edges out and wins. Although I am really curious what's gonna happen if I like make this one like have like a slanted front almost. Let's do that real quick. Yeah, look at that. That's awesome. That is awesome.